Here's the bell work for the day using the formula for distance equals rate times time. Find the distance covered by an airplane flying at 450 miles per hour for 4 hours. So that's what we're going to do. And it says distance equals rate times time. I've heard some students call this dirt. So what did they give us in this problem? Well, they said that it was flying at 450 miles per hour. From what we learned in 7th grade, that's a rate because it's a comparison of two quantities, miles and hours right there. So I'm going to go in and replace R, the rate, with that rate it just gave us, 450. And I'll put it in parentheses just because we're multiplying it by the time. And then the 4 hours, hours is a form of time. So I'll replace my T, which does represent time from the formula it gave us in the words, with 4. So when I figure this out, it will tell me the distance, and it would be the distance, the label for the distance is part of the rate, which is shown right there, and that's not meters though, it's miles per hour. So we'll be sure to label this in miles. So I just put 450 times 4 in my calculator, and it gave me 1,800. Once again, just don't forget the label here on miles. That's all we would need to do right there. Right now we have a quiz. This is not a mastery quiz, it's just a quiz, 40% of the grade. So we're going to take about 10 minutes to do that, then we'll start on the lesson, okay? Here's our objective for the day. I can distribute and combine like terms for any math expression. There's a lot of vocabulary in this lesson, but take 1 minute and copy that down on the classwork, okay? A little bit of vocabulary, right? Terms, like terms, and coefficients. These are some main terms that we use quite often, not only in this unit, but pretty much every other unit that we're going to be seeing. You're going to hear a lot of this terminology. Okay, so a term is just values or variables in a math expression, but they're separated by addition or subtraction. This is kind of the key point right here. They're separated by addition or subtraction. So if there's any multiplication or division in between addition or subtraction, then it's considered its own term. So sometimes you could see a term shown as I don't know, 3a over 2 like this. That's still considered a term, okay? Because it has multiplication and division within it. Well, among all the terms, it's possible to have what we call like terms, and that's just where the variables have to match. Okay, sometimes there's more than one variable. Usually, for now, we're only dealing with one variable at a time. Usually, that variable is x. So another term that has an x, like a 2x, like this, that would be considered a like term, because it has the same variable. Sometimes you'll see straight constants like this, maybe like 9 and -7, like this. Those would be considered like terms as well, okay? Now, in the past, we kind of distinguished between minus and negative, but now the minus sign, because each term will take addition or subtraction with the sign, it takes a sign or the operation to its left as its sign. There we go. But these can be combined to simplify an expression. That's true. Now, it's possible from time to time you'll see many different letters used. So you could have an X and also perhaps like a Y, like this. And these would still be considered like terms because the variables match, okay? Now, I don't think we're going to see a lot of exponents, but if we do, we have to consider those other like terms. So if you saw something like x to the power of 2, and then another x to the power of 2. These are like terms, and it wouldn't matter what the number is in front, like 4 maybe, okay? So these would be sets of like terms. It's possible to have more than 2 at a time. And then we have this word coefficients, okay? So the coefficient is the number that's being multiplied by the letter. That's a very quick way to put it, okay? But once again, the coefficients will take the operation, whether it's addition or subtraction, as its sign. That's to its left. Okay, so if I saw something like, I don't know, 3 minus 4y like this, I wouldn't say that that's a positive 4y anymore. I would say it's a negative 4y like this, okay? And the coefficient would be -4. You'll have to be careful because when we ask for a coefficient, you do not want to put the y in as the coefficient. The y is considered a variable, which was part of the lesson that we went over last time in 1.3, okay? So there's terms, like terms, and coefficients. So here's an example of some coefficients that we may see. These ones end up being more tricky than we wish they were. But that's why we're going over these, so that we can clarify what the coefficient of these values would be. So to start, let's look at this x, right? It's negative x, okay? So you'd say, well, what number is being multiplied by the x here? That's a phantom 1 right there. So the coefficient itself is just negative 1. Again, we wouldn't say that it's negative 1x, because the x is a variable, not a coefficient. The coefficient is multiplied by the variable. That's the difference. So what about one like this? It's the same thing. Remember, some students would even notice the phantom 1, so they'd say 1, but that's still incorrect, because it will take the sign to its left. It will take the operation to its left as its sign. In this case, it's minus, which would make that a negative 1. So the coefficient here is negative 1. Well, what if we just saw an x like this one? Well, once again, it's a phantom 1, which makes the coefficient a 1. So there's those three. Yeah, we got negative 1 here, and 1 there. Now, the reason why we're showing these is because phantom 1s tend to trick people, or trip them up a little bit. If it was a regular number, if we said, hey, look, what's the coefficient here, 5x? Well, a lot of students then would know that the coefficient would be just 5 in that case, okay? Now, this is a pretty big expression right here. It says that we're going to identify all the terms, like terms, coefficients, and then we'll simplify it in the end. Now, when it says simplify, that means when we do find like terms, we will combine them, okay? So, let's make this just a little bit bigger. No, that's okay. All right. So, we identify each of these terms. Geez, how many terms are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 terms, okay? That's not too bad. But the first term that I see here, 4x. So that's my first term, 4x. Now I'm listing it above just because of space, all right? But the next term, so I'll put a comma there, is 6. Now that's positive 6 because of the plus sign to its left. And then the next term, 2x to the power of 2. There we go. Then the next term, negative 9. Now again, this is not just 9. It's not just 9. And it takes that operation to its left as its sign. Since it's minus, it becomes a negative 9. Then we have, again, not just 5x to the power of 2, but it's a negative 5x to the power of 2. Then the next term, again, it's not just 12x, it's negative 12x because of the minus sign. Then the next term, now notice I'm not putting the positive signs with the positive values because we don't have to, it's just 4. Then the next term, negative 5x. Then the next term, 3x to the power of 2. Then the next term, 4. Then the next term, so I'll go down to the next line here, 3x. Then the next term, negative 6. Then the next term, 2x. And then finally our 14th term here, x to the power of 2. Now, this is x to the power of 2. Some of you would like to show that as 1x to the power of 2, and that's fine if you do, especially when we look to combine the like terms, okay? So we've identified all the terms. Now let's go in and identify all of the like terms. And once again, I'm just going to start with the first term here, and then I will find all the other terms that are like it. So that is 4x. Now this has an x, okay? It is not x to the power of 2. So when we scan this for other like terms, of course 6 doesn't have an x, so that can't be a like term. But the 2x to the power of 2, it has an x, but it has an exponent of 2. So this is not considered a like term with 4x. It's just an x. See that? So that's not considered a like term. Negative 9, nope, not a like term. Negative 5x to the power of 2. Again, that power of 2 is what makes it not a like term. And then, oh, now we got negative 12x. Yes, that will work. That is a like term. It's a negative 12x there. Continue scanning. 4 is not a like term with the x's, but now I got a negative 5x. Yeah, that's a like term. Negative 5x, because again, it does not have the exponent of 2. Now the 3x to the power of 2, nope, because the exponent. 4, nope. 3x, yes. That has just the x. So I'll list it in the x terms as a like term. Then I got negative 6, no, 2x, yeah, that'll work. That's a positive 2x. And then finally that x to the power of 2. Nope, that's not a like term, okay? Now that identifies all of the x terms. Now because I'm always scanning from left to right, my next term here is a positive 6. That is what we call a constant. Not that I think anyone cares, but it becomes its own type of term. So what are some other like terms that don't have x's? Well, the next one I see here is negative 9. So I'll list that there, negative 9. And then we got a positive 4. And then another positive 4. And then a negative 6. That would be all of the like terms without x's. And yes, I was deliberately skipping over the x terms and also the x to the power of 2 terms, okay? But the final type of term we have is this x, not just x, but x to the power of 2, right? So that, and that's a key point here, is that it does have that exponent of 2. So we need to find all of the other terms that have x to the power of 2 terms, but let's list 2x to the power of 2 first, okay? Well, it pretty much should be all the rest of them. So there's a negative 5x to the power of 2, negative 5x to the power of 2. And then the next one, a 3x to the power of 2. And then the final one, again, you can show that as 1x to the power of 2 if you'd like. You don't have to, though. But the one will be helpful, I think, when we start to combine the like terms, okay? Now, what are the coefficients? The coefficient is multiplied by any letter or letters. It's the number that's being multiplied by those, okay? So what are the coefficients here? Well, they're just the numbers being multiplied by the letters. So let's see if we can identify those. First one I see here, 4. See that? So that is considered a coefficient because it's being multiplied by the x. What about 6? No, that's not a coefficient because it's not being multiplied by an x. All right, what about that 2? Because it's x to the power 2. Yes, it's being multiplied by a letter. It is considered a coefficient. So there we go. It goes in the list. Negative 9 is not because it doesn't have an x, but this negative 5 does, even though it's a x to the power of 2. But again, this is not just 5, it's negative 5 because of the minus sign to its left. So negative 12 would be also a coefficient there. And then we got negative 5 there. Again, I'm going to list it twice. And then there's that positive 3 there. And then the 4 isn't, but that positive 3 is. So there's another 3. And then we got this 2. And this last one here, again, it's that we can't see it, but it's there. That's that phantom 1. So I do need to put it in the list. Okay? Now that is all the terms, like terms, and coefficients. So the last thing I'm going to do here is combine the like terms. So you could say in between these you have all the operations, right? So if it's positive, it's plus. If it's negative, it's minus. And then we can figure out what this would be here in the end if I combined all the x's. So 4x's minus 12x's minus 5x's plus 3x's plus 2x's. I can put that in the calculator. Just 4 minus 12 minus 5 plus 3 plus 2. Enter, and I get negative 8. So this ends up being negative 8x's. And I'm going to list it up here because if I combined all my x terms like this, not that that's so pretty, but it's a negative 8x right there, okay? Now I will combine all of the constants. So that'd be 6, negative 9, 4, 4, and negative 6. I'm trying to use different colors to make this pretty. But that'd be 6 minus 9. Again, the positives are pluses. So plus 4 minus 6. Enter. And I get negative 1. Now this one doesn't have a variable with it, so it just shows as minus 1 in the expression. So negative 8x. Again, that's a minus 1 because it's a negative 1 when I combined all those like terms. Finally, we have all of our x squareds. So that's 2x squareds minus 5x squareds plus 3x squareds plus 1x squareds, right? So that's 2 minus 5 plus 3 plus 1. Enter. And I get 1. So that's 1 of our x squareds. So if I were to have combined these, which I have done already, that ended up being a positive 1x to the power of 2. I'm going to make that a phantom 1 just because I think it looks better, but you don't have to. There we go. That's the simplified expression right there. And some of you may be wondering about the order. The order doesn't matter as long as the sign to its left, or the operation to its left, matches the sign. So you could say negative 1 plus x to the power of 2 minus 8x, and that would work too. So this is a good illustration on what terms are, like terms, and coefficients are, because once again, when I say, hey, what's the coefficient of x, you need to know what that is, especially since we've already been, I think we've been doing that, or we will do that with some solving equation stuff. All right, along with solving equations, because that's what this is kind of a precursor to, is we have to be able to use the distributive property. The distributive property usually looks like this, okay? It's double rainbow. And for those of you that are old enough, not that I think you are, but back in the day there was a video that went viral about a full-grown human being that was crying over double rainbows, but whatever, okay? But that is what this is. You will notice, and you will need to notice, that the distributive property or distribution, it is considered multiplication. And this is important because the order of operations. Okay, you have to do multiplication in a certain order. So we use distribution essentially to get rid of the parentheses. And see how it's not showing an operation between these two values, or the a and the parentheses? That's because the only operation we don't show is always multiplication. So that's, just understand that distribution is always multiplication. Now, if these were values, like, I don't know, 2 and 1 right here, right? And we had this in parentheses, maybe the a is a 3. You could say I'm going to distribute the 3 like this. But that would be kind of unnecessary because you could use the order of operations to combine 2 plus 1, which is 3. 3 times 3 is 9, okay? The only time we usually have to use distribution is if there's an x somewhere in there, like here. Once there's an x, then we have to use multiplication to get rid of those parentheses, and that gets rid of the parentheses for us so that we don't have to worry about that part of the order of operations once we start to solve equations like this, okay? So the distributive property, when we're not solving equations, just evaluating expressions, we don't really need it, but once we start seeing x's in the equations, then yeah, we're going to need the distributive property. Now, some students would look at these two examples that says simplify and say, well, this is just multiplication. Well, multiplication is distribution. So I'm going to show this as distribution. It's just that there's only one rainbow, which is not nearly as exciting as 2 rainbows. But that's 6 groups of 4 x's. So when you combine these, 6 times 4 is 24. That's how many x's you got, 24 x's. Now, it's possible to distribute letters, which you'll need to understand. And again, I'm only distributing this into one value. That's m, groups of 8 m's, so that's 8. But now how many m's I have, right? I have m times m. I'm just going to simplify that into m to the power of 2. I don't know. I think it looks better, but whatever. So just understand that it is possible to distribute into one term alone because distribution is just multiplication. But from time to time, you'll need to distribute into 2 values, like we've seen. So in this example, I got 14 groups of A. Now you could say 14 times 1 if you'd like. 14 times 1 is 14, and then that's how many A's we would have here. But then the second part of the distribution, that'd be 14. I would say that's times negative 3. So, well, I can do it with the calculator for that. 14 times negative 3 is negative 42. Now I write this as minus 42. The minus makes that 42 a negative. So this would be considered fully simplified. If you were by chance to put plus negative 42, I think that on Canvas it would mark that incorrect. So be careful. We don't want plus minuses anymore or minus negatives anymore. We can use either keep, change for that, but with distribution we shouldn't have to worry about that, okay? 14a minus 42. And once again, this is distribution into 2 values. Well, we distributed into 1 value, and we distributed into 2 values. Can you distribute into 3? Yes, you can. It's not this problem, but we can, okay? So this example here is to show that you can distribute from either side because it's multiplication, right? So I would probably say distribute furthest to the left first. Make that a little bigger. So that's 13 times 1x, that'd be 13 x's. And then again, I would say this is 13 times negative 2y's. Well, 13 times negative 2 is negative 26. That's how many y's you have, okay? And again, I show this negative as minus now. So we end up with 13x's minus 26y's, done. All right, here we go. Can we distribute it into 3 values? Yes, we can. So I'm going to take that negative 4 and distribute it into the 6x's. So again, that's negative 4 times 6 of the x's. So when I combine that, how many x's would I have? It'd be negative 24 x's. Okay. Now, if you don't know what 4 times 6 is or negative 4 times 6 is, put it in the calculator because it knows. Now, this next one, I would say that's negative 4 times negative 7. So when I combine these, I end up with positive, because of the 2 negatives, 4 times 7, 28. So that's positive 28. And then this third distribution, and yeah, you can distribute 3 or more times even, but here's 3. So that'd be negative 4 times 4 z's. 4 times 4 is negative 16. That's how many z's we have right there. Now, the order doesn't matter here, but I would just keep in this order. And that would be considered fully simplified at that point. Now, the last thing on this one, a lot of students would say, can't I combine the x's and the z's? No, they're different letters, so you cannot combine these. These are not like terms. And I kind of deliberately use different colors here, not just to show the distribution, but to show these are different, they're not like terms. There we go. All right, on problems like this, one of the main issues we see is that students want to distribute this 3, and they'd even say distribute negative 3 right there. But remember, a term is separated by addition or subtraction, right? So the 3 isn't even part of this term right here. And this is considered a term because it's in parentheses. Well, we are distributing something. What are we distributing? It's a negative 1, okay? It's just a phantom 1. So I'm going to show my distribution rainbows here. There's 1, there's 2. So once again, the first distribution, negative 1 times, you could say 1x if you'd like. That's how many x's we will have. Negative 1 times 1 would be negative 1. And then also, that second distribution, negative 1 times positive 6, would give us negative 6 there. Now don't forget the 3 out there in the front, because in this expression, I now have like terms that I can combine. So I will need to combine them. That's the 3 and negative 6. Now again, 3 and negative 6, you could say 3 plus negative 6, you can say 3 minus 6. Either way, you should get negative 3. There was no like terms to combine with my negative 1x. Again, you could, if you wanted to, write this as a negative 3 minus x, if you want. But it's not required. Either one of these will work. All right, this one's kind of big, but we got double distribution. Try this one out. Take 1 minute, try it out on the classwork. And then we will go over it together so you can check maybe where you made some mistakes or if you have it correct. 1 minute, go. So, the first thing I'm going to need to do on this one is some distribution. Let's make this a little bigger. So, I'm going to start with this one on the left with the 8, okay? So that would be 8 times 3x's, 8 groups of 3x, which would be 24x's. And then I would have 8 times 7, which would be positive, because these are both positive. Positive 56. Now, I'm not worried about the plus 13x. I'm just focused on distribution right now. So I'm going to distribute. Again, this is not just 3. It takes that operation to its left as its sign. So this is really negative 3 times 4x's. So how many x's would that be? Negative 3 times 4 would be negative 12. And then I'll have to distribute it into the 6 there. So that'd be negative 3 times 6, positive 6, which would make negative 18. So the only term I didn't work with here was that positive 13x, so I'll just show it as plus 13x right there. Now you may say, well, that's not simplified. That's true, but it did get rid of the parentheses, so I don't have to worry about that order of operations business because that's what distribution does for us. Very nice. But now what I will do is combine any of the like terms. So I'm looking first, it looks like, for x terms. So there's my 3x terms, right? 24x's, 13x's, and negative 12x's. If you need to, stack and add those, but these are all x's right here. So let's see, we got 24, we got 13, and we got negative 12. I can just type this into the calculator. So 24 That'd be positive 13, so plus 13. And then minus 12. Enter 25. So that's how many x's I have, 25. The only other terms I have here are constants, so that's 56 and negative 18. So once again, I'll just put this over here, 56. You can say 56 minus 18 if you want. 56 and negative 18. 56 minus 18, enter. I get 38. Now that's positive 38, so I will show it as plus 38. And so, yeah, we only have the two types of terms, so that's considered fully simplified. Yeah, we only had x terms and constants. So even though there were 5 terms here, after simplification or combining like terms, we ended up with just 2 because there was only 2 types of terms. That's it. Here's another one. Let's go over this. We'll simplify it. But there is parentheses, which means that we will need to use some distribution. Once again, this is not a distribution of 2. It's a distribution of negative 2. So that's negative 2 times 8 n's, right? So when I combine these, how many n's would that be? Negative 2 times 8 would be negative 16. But then we also have negative 2 here. That's times negative 1, right? Because it's minus 1. So it's negative. Negative 2 times negative 1 is positive 2. So I show that as plus 2. I still got my negative 9 in there. And although there's 3 terms, 2 of them are like terms, the n terms. So how many n's is that? Once again, I show that as negative 9 minus 16 right here, which appears to be negative 25. Just put that in the calculator if you need. That's negative 25 n's. And then, yeah, that positive 2, it just drops because there was nothing to combine it with. Okay, so that would be considered fully simplified. Some of you may even choose to make that 2 minus 25n, and I believe that should work on the assignment if you saw something like this. All right, here's another one, and yes, there is some distribution. We do have 2 different letters, which hopefully is okay. But once again, that's negative 2. I'm going to show that phantom one, although you don't have to. That'd be negative 2 times 1w. So how many w's is that? Negative 2 times 1 is negative 2 w's. We also have negative 2 times that's positive 3, which would be negative 6. Nothing else changed, so we still got plus 6w and plus v. So do be careful. Even the v kind of looks like a w, right? Like a half w, but don't be tricked on that. They are not like terms, very different, okay? So I will combine my w terms. This will tell me how many w's I have. Well, how many did I have? I had negative 2, and I had a positive, that's be 2. Negative 2 and a positive 6, which when I combine, I get positive 4 there. So how many w's do I have? 4 of them. Then I also have this negative 6, nothing else that was like to combine it with, and then also this positive v there. Now I see I have only 3 different types of terms from the original expression, so that's it. That's it for this one. All right, yep, we see more distribution. It's good stuff. And we'll distribute the 6 into this parentheses. This first distribution, again, distribution is always multiplication. So that would be 6 times 3, which is 18. But also 6 times, that'd be negative 9x's. 6 groups of negative 9x's. 6 times 9, how many x's is that? That'd be negative 54. Okay, so that's negative 54 x's. We still have the 8x out there on the left. And that's a positive 18 because it's plus 18 because it's positive. Now we will combine any like terms we see, and there's only the x terms to combine. So how many x's will this result in? Well, we had 8 x's, and then we also had negative 54 x's. So 8 minus 54, you can put that in the calculator, or negative 54 plus 8, either way. I put in my calculator, and I got negative 46. So I'm going to show that as negative 46 x's. Then the positive 18, yeah, it just drops because there was no other like terms to combine it with. That's done. All right, there's our objective. Again, I can distribute and combine like terms for any math expression. Just can you simplify expressions is really what it comes out to. But hopefully you feel pretty good about that.